presentation. Please feel free to stop me at any point with questions. There might be a little icon up in the upper left corner, Sue, that will allow you to turn your mic on as well. So you might try that. But unless I hear that you're not ready, I'm going to go ahead and begin. Okay. All right, so this is about, we're going to talk about performing analysis and ArcGIS Online. So I'm going to go over some of the requirements and notes on those requirements to perform analysis. I'm going to talk about my data sources and some of the recommendations that they suggest in that environment in ArcGIS Online. I'm also going to just quickly review some of the pre-work that I did before, maybe specifically to bring the data up, but also to perform a specific analytical task. So the analysis that we're going to review includes summarize data, find locations, data enrichment, analyze patterns, use proximity, and manage data. These are all the options in the perform analysis environment. And then I'm just going to have a few final notes that I'll review. Okay. And again, please feel free to stop me at any time. Now, you will need some privileges to use any of the analysis tools. So, in other words, to create, update, and delete content, you'll need the necessary privileges. It could be just, giving you an organizational account. It could be just an advanced, selecting the advanced option. You will have to be able to publish hosted features, and you'll also have the spatial analysis features selected as part of your privileges. So this is done by the administrator of the organizational account. So again, that's a discussion how those organizational accounts are being set up. Right now, I believe Mark is your administrator. You may also need an advanced software version. Again, this is within the environment. So network analysis or network analyst and geo-enrichment. You access the perform analysis tools through the perform analysis option. So you're going to select the drop-down menu or right-click on the data set, click on the perform analysis option, and then the analysis will be performed on the data set selected. You can use additional data sets, or I believe your option would be one additional data set, as well as fields within that data set as part of your analysis. It just depends on what type of analysis and what options you have. So the data that you can use and the recommendations include, you can use the feature service. Yes, they will. They will be, I don't know that the slides will be available, but the webinar will be published. So you can use a feature service, a map service, comma-separated value file, KML layers, GPS exchange format file, that's the .gpx extension, shapefile, which always has to be uploaded as a zip, GeoRSS web feed, map notes, and route layers can all be used as data to perform analysis on. It is highly recommended that you always use the current extent option. This option is by default selected. What that means, it's just going to be the extent of the map window itself, the map viewer in ArcGIS Online. This will help in terms of reducing the amount of analysis that has to be done in terms of the area, which in turn won't take as long and perhaps it won't crash. So I did have some issues in terms of the just basic analysis I was doing. I found it kind of clunky, but we'll talk about that. So my data sources included the AZ Geo Clearinghouse. So you do need to create an account to download data, and I believe, no, you don't have to be associated with the group. The data I downloaded included schools, cities, points, counties, wilderness areas, and tracts at the statewide level. They do not download, I don't believe, yeah, they don't have downloads for the county-specific data, unless it's county data. I believe Yavapai does have some parcel data up there, so it's specific to Yavapai. There might be some county-specific data, but generally it's all statewide data. All of the data are projected to NAD 1983 Harn UTM Zone 12 North, so you don't have to worry about having to make sure everything is in the same projection. So that's kind of a nice option there, or a nice benefit of downloading from the same website. And the fact that it's projected, it's not in a geographic coordinate system. So the pre-work that I had to do, when you are uploading to ArcGIS Online, you are restricted to 1,000 features. So if you have a data set that has 100,000 features, which is not unusual, you will not be able to upload it to ArcGIS Online. Your maximum number of features, in other words, rows in your database, features in the geometry, is 1,000. So I was going to work in Maricopa County, but there are more than 1,000 tracts in Maricopa County. So I looked around, just kind of viewed some of the data, and I decided to work with Yavapai County, so it looked reasonable. So that's what I did. So what I did at the pre-work in ArcGIS Desktop, I went ahead and selected all of the cities, schools, and wilderness areas that are located within. Basically, I chose, you can see down here, their centroid was located within Yavapai County. So that gave me all of the cities, schools, and wilderness and tracts. Oh, I don't have census tracts listed there, but the tracts that were located in Yavapai County. So again, I did the select by location option within ArcGIS Desktop. So my final data, as far as the geometry included, and of course this is being displayed, this is from within ArcGIS Online here, this is just a screen grab, include the orange dots are the cities in Yavapai. The green dots are the schools in Yavapai. Of course, the green areas are the wilderness areas that obviously you can see they go outside the county boundaries. And then the blue areas with the black outline are the tracts, census tracts. I'm not going to go over the attributes. You'll see some of the attributes that I select on, but the Yavapai tracts, census tracts, I tried blocks, but there were too many block groups. So the tracts were the ones that were more manageable. They have all of the household characteristics and the age groups, median age, total population. So there's lots of fields already there. You don't have to go up onto the census site and perform all those joins and download the separate data, unless you want to kind of learn how to do that and play with it a little bit. So the first thing I did, I just went down the perform analysis. I just sort of said, okay, I'm just going to go linear right down the list. So the perform analysis first option that you get is summarize data. Summarize data will give you total counts, give you length, area, basically give you some descriptive statistics of a featured data set based on either just simple counts, or it can be based on a field within the attributes. So you can also select, obviously you're going to have a selection of another data set. So you'll see I have some examples that I did, and you'll see what you can select on. So when you're in summarize data, you have several options. You can aggregate points. So in aggregating points, this little graphic gives you the input and output. You can see it requires a point and an area feature. So what you're doing is you're saying how many points are within each area. And what it does, the simplest, is just gives you a count. And then you'll notice it has these circles because basically it symbolizes using proportional symbols. So you can see the 9 is a larger circle than the 4 and the 2. So you can also, again, that's your basic statistics, but you can also do summarize basically on a particular field within an area. And again, I have some examples that will show you how that's used. Summarize data, summarize nearby is your second option. And again, you're looking at, you can think of this as sort of a buffer operation, really, because you're trying to find those points or those features that are located within a specified distance of other features. Your default is a straight line distance. You can also get drive time distance or drive distance. If you use drive time, you cannot, let me rephrase that, you do not have the option of drive time distance and drive distance if you do not have a route data set, or those would probably require the network analyst. I'm not sure if straight line distance requires network analyst because it's just a buffer distance. But the drive time distance and the drive distance requires a route data set. You build the route data set in ArcGIS Desktop. If you do drive time distance, you will need a field that lists the speed limit. So think about when you do a MapQuest or a Google Drive directions and it gives you the time it'll take to get where you're going. The only way it can do that is by, one, it has a route data set, and second, it has a field with the speed limit. So it's basically just doing your distance rate calculation. So those are pretty, building a route is no easy task. I thought maybe I wanted to test to see if I could use the street data in ArcGIS Online, the street option for your background layer, your base layer. That is not an option. It does. So basically, because I didn't have a route layer, these two options were not even available to me. So the only option I had was the straight line distance because I didn't have a route available to me. Even though I was using the street as my base layer, the street is not an option for you to use as a route option. So another part of the summarize nearby is basically statistics calculated for nearby features. So again, you're looking at sort of a proximity, but you're summarizing information. So you can see a question would be the total population within 5 minutes of a proposed new store location. Anytime you see this 5 minutes, you're going to need a route. So, or not just 5 minutes, could be 10 minutes, could be 2 hours. But anytime you see a time, you need a route with a speed limit field. Here you're seeing the number of freeway access ramps within a 1 mile driving distance. So again, driving distance, you're going to need a route. So, unless you have the time to develop a route layer or you have access to a route layer that has the speed limit, you might be would behoove you just to stick with the straight line distance. So I think this is the last option for summarizing data. This is summarize within. So basically you're looking at features within the boundaries of areas in the analysis layer. So in other words, the analysis layer is the one that you're selecting on. So in other words, you've got it selected and you select the perform analysis. So what you're saying is you can see the input here. So your analysis, it's going to be an aerial feature. And then your other input would be this linear feature. It's saying, okay, right here, these features. So some examples would be find watershed boundaries by area within a county. So calculate the total area of the watershed by county. It's almost like a union. I look at this as almost like a union or maybe an intersect. Here, calculate average median household income within a city boundary. But again, you can see that this is the data that you would have to have available to you. Now, they do have some data enrichment. You'll see the data enrichment is pretty handy because you can actually use the ArcGIS Online data. Again, please feel free to stop me at any time. So these are the next couple of slides are my examples of doing the summarized data. So this is the aggregate points option. So I've tried to show you what I chose. So my analysis layer are the Yavapai schools, the green points. And I'm looking for the area, and the area I chose was the Yavapai tracts, so that's the darker border, right? So my statistic field, I didn't choose a statistic field, but I did choose one to group by, and that was grade. And then I just decided, I'll add minority and number of percentages. And those are added as additional fields in the result set. So here's my result layer. And notice use current. Use current means use current, or it has map extent there too. That will be selected by default, and I suggest that you leave it on, because if you have a nationwide data set, it would probably crash or just take forever. Of course, you click Run Analysis, and then the result set, I went in and changed the symbols. So I used the size option. In other words, that will give you proportional symbols. And then just show me the count of points. I didn't normalize it because I just wanted to see the count of points, and then I have 5 classes. So you can see that I think it went from like 1 up through 5. So I have 5 schools, right? So notice my objectives were count the schools located within the census tracts in Yavapai County, group them by, right? Choose a field to group by the grade field in the Yavapai schools layer. And then I symbolized by size on the count of points. So I have a final map here, I believe. Yeah, so here's my simple count map. So here, this is the legend. Now, one of the things that I found out, because I looked at this, I'm going, how can I have 5 schools here? There are only 2. Well, guess what? There's more than 2. If you zoom in, there's actually this, even though it looks like 1, there are actually 2 points there. So there's probably 3 up here, or there could be another if I zoomed in even closer. So even if you use a different symbol, it doesn't really help. So you really want to make sure, because that's the thing. I'm looking at that and I'm going, wait, there's only 2 schools. But you really want to check your data. So, and this, obviously, I'm just doing a simple count. It's going to be clustered in these areas. This is Prescott. So again, you can see in terms of the proportional symbols, just know that they're going to be placed at the polygon centroid. So that's why, they're not going to be placed over the points. They're going to be placed at the center, at the centroid, wherever that centroid is located of that polygon. So the question that I looked at it, I said, well, does this tell me anything, really? It doesn't really give me any additional information. It doesn't enhance anything. It just kind of gives me what I already knew, right? Told me how many schools were in that area. So what I decided to do on the next one, I said, okay, because I'm wondering what schools are located in a census tract, does it make sense to use median age, which is the only field available? You have the age groups, right, broken down from what, 5 to 9, 9 to 14, but you can't select that many different fields. If I want an aggregate field, I can have median age and I have total population. Sorry, my time clock is going off. So I'll wait until it stops. So I decided that really I'm just trying to see if these schools are located in the tracts that have the school-age kids, right? So I decided that school-age kids would be the 5 to 9 through the, I think it's 18 to 24, 20 to 24, because there are also colleges included in that data set, in the school data set. Now, again, this is not a highly thought out analysis. I did this really quick, so I'm sure there are problems with it, but I just thought, I'm just doing a demo. So I decided, well, I'll just combine those fields into a field called total 5 through 24, and that gives me the total number of really school-age children and adults, obviously, through 24. I had to go back out to ArcGIS Desktop, and you can't really zoom in on this in this environment, but basically I just created an additional field, called it total, or tot5_24, made it numeric, and then in my field calculator, I just chose the 5 to 9, 9 to 14, and added those up, summed them up, and then that's what gave me the values for that field. So now I have the total number of what I consider school-age children. Obviously, it would take a little bit more exploration to make sure that that is, in fact, true. So that's going to tell me something. Uh-oh, Kelly's gone. So the result set, as you can see here, aggregate of Yavapai schools, right? There's my total 5 through 24. This is the data set that was created as a result of that first analysis that I showed you, where I said count the number of schools in a census tract. What happens is all of the census tract fields come over to, and I created that field before I brought the Yavapai County set in, so that's why it occurs here. So all of the fields come in when you do that. When I did that first analysis, all the fields came with it from the tract layer. So again, the result set includes the fields from the Yavapai census tract data set. So now I can symbolize by size, right? Proportional symbol, that's what size means. On the total 5 through 24, I don't have to do any other analysis. I just have to change my symbology on that field that I created. So you can see I did that twice, right? Because so now I can compare. So I'm symbolizing on the 5 through 24. So notice what's happening up here. This is the symbol count. So this might be a better representation of what's happening in terms of school-age children. Does that make sense? Any questions so far? Okay, I'll take that as a no. All right. So I can actually do an overlay. I can actually bring those in and symbolize them so you can see, just so that you can see the difference between the two. This is the median age. That's why it really didn't tell me very much about school-age children. This is the total 5 through 24. Remember, median age also comes in because it's in the original tract layer. So in that way, I can see, does this make sense? Or do we have the schools in the locations where we need to have the schools? And again, I can visualize, I can compare. All right? Again, feel free to stop me at any time. So the next one I wanted to do was aggregate points. It's still the aggregate points, but I want to summarize by a field value, right? So it can be either one, Kelly. I mean, it depends on how much you want to show them. So in other words, if you're just trying to show them, if you're trying to teach content, and have them look at spatial relationships and explore data, then you could have it already prepared. Or you could, if you want to teach them how to use data to actually prepare data, then you would have them prepare the data and start data and develop those fields. It really depends on what you're trying to teach. I am trying to teach GIS skills, so generally I have the problem set out and I have my students do the work of preparing the data. So summarize, okay, you are welcome. So summarizing the field value, again, this is I'm doing Yavapai cities, because you need, my understanding of this operation is you need an actual numeric value. It can't be a categoric value. It has to be numeric. So I know in my school data, my original school data, I don't have numeric data per se. I have grade, I have element, whether it's the type of school, but I don't have any kind of population. In the Yavapai tracts, or in the Yavapai cities, I actually have a population count in the cities. But those cities are located within tracts, perhaps, or associated with a tract. So again, this is the analysis layer. I'm going to compare it to the Yavapai tracts. The field that I'm going to look at within the Yavapai cities is population. I'm not grouping by a field on this output. So again, here's my result layer. Notice again, use current map extent is by default selected. I click run analysis. Now I've included the description if you want to group by a field. But in this case, I didn't do that. So again, the Yavapai cities are point data, and the average population is the statistic. So I chose the statistic here. It has just basic description, sum, median. I chose average. But again, I'm not grouping. I just wanted to let you know that you could group it by a field. I'm not, and here's what grouping by a field would do. So this is my input for summarizing by field value. Displaying it, so here's my legend. Again, I'm displaying by size, and that really is typically what it defaults to. But again, notice I have plenty of cities up here, but I have no value. There's no symbol. So of course that was like, hey, did this really work? Did I do it wrong? I thought I did it right. What's going on? So I go in and I click, right? Because I want to see what the value is, because I'm thinking it has to be 0. And it is 0. The population is, where it is 0. So I didn't check all of them, but I'm making the assumption that they're all with a population of 0. Now, why that is, it could be there's a threshold in terms of what they're recording. You'd have to find out why is there basically that's a null value. Maybe they have a minimum value that they consider, if it's less than 100, then, it's a 0 population. But again, you'd have to kind of explore, do some data. But this, again, when you're looking at it, you're going, hey, I know there's cities up here. This is my city layer. Why don't I have any kind of values in here? So that's why I'm saying you want to review your data values to make sure that they're correct. So that's what I did. I just selected one. I said, okay, these are probably 0, but I need to check and make sure. Okay? All right. Again, any questions, feel free to stop me. So the last one is summarize nearby. So in this one, I just kind of showed you my inputs because it was really, if I wanted to aggregate, the online environment is kind of clunky. You can't see things all at once. You have to scroll, or even the legend. You can't do a legend all at once. All the items in a layer. If you have 4 or 5 items in a map document, you can't see them all in the legend at one time in that mapping environment. So when you see the legends that I've produced, if there's more than one item in the legend, I basically did a screen grab and combined them. So that's the same here. This one was too long. If I shrunk it up, to fit in the length of the slide, you couldn't see it. So I decided, okay, I'll just break it out into steps. So again, I'm doing size nearby. My input is the result set of that first analysis that I did, right? The aggregate, the Yavapai schools according to the tract. So that's my analysis layer. And then I'm going to summarize based on tracks again. But notice I'm doing a find nearest features using, and notice I don't have a driving distance or driving time availability to grade out. The only one I have an option for is the line distance. So what it's basically saying here is basically create a buffer around each of the Yavapai tract boundaries. And that buffer is going to be basically a 5-mile linear distance. So the third option is do some sort of statistics. So I'm doing total 5 through 24. That's my statistic basically. And then I'm not grouping on a field. I'm not doing a minority or percentages, none of that. And then here's my result set. I run the analysis, and again, it's basically you're saying find the nearby features, summarize the features within a buffer distance. you can only use point features as the analysis layer. In other words, your selected layer, okay, in this operation. All right, so those are my inputs. So the result set, you can see, here's the buffer. I went ahead and re-symbolized changed the symbology on the original layer so that it's the census tracts are white with black boundaries. So you can see the buffer distance around that boundary is 5 miles, but notice it's also around the entire, because the outside, because that's the outside of each, of those particular census tracts. So notice it's a gradient color. I chose 9 classes. So again, I've got it outlined here. So I'm displaying on the total 5 to 24 field. I've normalized it by % of that total. And then I displayed it according to 9 classes, and it's a graduated color ramp. So in other words, the darker the color, the greater this value. All right. So again, feel free to stop me, ask questions. So my final map, again, I created this as a result of 3 or 4 screen grabs. So here would be my legend, right? Here at the green dots are the schools. Here's the % of the total, basically, right? And then here are the tracks themselves. So again, that's how you would get that. But again, anytime when you do that sort of combined analysis, when you have that reference data set, those attributes come into the result set, which is kind of nice. So again, I overlaid that map, right? This is the background is the previous slide. So then I just said, well, I want to see the schools. I want to bring in those, and this is by grade, symbolized the Yavapai schools, the original data set, by school, by the grade. In other words, the grades of the school. So that is telling me, that kind of gives me an idea, right? I could also overlay with population, what have you, okay? But I've already got it aggregated by population. So there's, and again, this is how I changed the symbols for the schools. So the next option in terms of analysis are find locations. So again, this is where you're basically doing some kind of expression, whether it's spatial or an aspatial query. Typically, you're using them in combination. You're selecting by an attribute and then by a location, or by some sort of spatial, an area or something like that. So generally, when we're looking at this, we're thinking in terms of multiple criteria. So site selection or suitability analysis are these kinds of analysis. So the first option, just finding existing locations. Not, basically you're saying, find those features that meet one or more criteria. So you can say, again, you can say, give me those features that are located within Maricopa County. Let's say, give me those census tracts that are located within Maricopa County that have a population greater than or less than 2,000. So that would be your combined query. That's your combined aspatial. Give me those features that with a population less than 2,000 that are located within the spatial part, which is located within Maricopa County. Derive new locations. This is where you're getting new data, right? And you can see that actually is happening with the summarized data as well. You're getting new data because you're sort of appending those fields to the result set. So this is sort of the same idea. So again, you're creating new features. So you're getting a result set that meet one or more conditions. Again, think in terms of spatial and aspatial queries. Derive new locations, right? So you're basically saying, I'm looking at the similarity or looking at locations that are based on or meet the conditions or multiple conditions specified by the user. In this one, you require one or more reference location data sets. So again, you're deriving new locations because you're combining. Some of these seem kind of redundant, but it just takes a little. So this is the example, derive new locations. So this is the second one. Okay, oops, sorry, you know what? This should be derived similar locations. So sorry about that typo. So I chose to derive new locations. So notice I have to build a query. You have to add that expression. You have to click there. So and I have the expression on the next. But the goal here is give me those wilderness areas that intersect Yavapai census tracts. So here's what your query looks like. So you have your wilderness areas. You have your intersect option. There are more options in there that are location based. And then the Yavapai tracts. You hit add, and again, this is a spatial query. So you can see here's my original data set here, with the Yavapai boundaries. Sorry, it still has the cities, right? Here are the wilderness areas. So once I say the result of that derived new location are just those areas of the wilderness that intersect the census tracts. Okay? All right. So the next set of tools are data enrichment. And again, this allows you to explore areas where you don't have a lot of your own data, but especially demographic data. So you can get some comparative information. This is the one where you can actually use Esri data in a really great way. So the lighting that you need to do this is geo-enrichment. And when you're looking at drive time, you'll need that network analyst privilege. So the enriched layer, again, these are your inputs, this is your output. So point or area data, and you have information about the people, places, businesses, demographic data, business, whatever data you can think of, really. Again, this is going to support further analysis. So you're going to get this new layer with all the demographic and geographic information that will allow you to do further analysis or just explore that result set. So here's what it's going to look like. I've selected enriched layer, and this is for the Yavapai tracts. So I selected the drop-down menu beside Yavapai tracts, selected perform analysis, and selected data enrichment, enrich layer. Again, you're going to select the data basically. So once it's going to list them here. There's nothing listed here because I haven't selected yet. So I click this button and I get the browser, a data browser. Well, I'm just doing a simple, so I selected income. I know you really can't see that, but it's going to be pretty generic. It'll do the same thing when you do this. So once I hit that, I go into another window, and notice I have these options. I have an option for the kind of data here to be more specific. I didn't select any of these. I just said, you know what? I want to look at food stamps and SNAP. I don't know what SNAP means, So I selected that option, which is right here. So this is what I get when I select that option. So you get the year, and so I select the first one in the list. So which is 2008-2012 ACS, which is the American Community Survey income, and 2008-2012 this is up here, 2008-2012 ACS income. And then this is the second level, which is 2008-2012 American Community Survey households receiving food stamps and SNAP. So once I select that, this is the same window, but I selected it, it automatically lists it up here. So there's a 1 up here. There's nothing selected here. So this is going to, I could obviously select more, and it would add it to that. Once I've selected I go ahead and hit the OK, and it brings me back to this window. And it lists it there. This is this is basically this window, but now I have a data set, demographic data listed. So now I can add some further analysis, but all I'm doing is just straight. Here's the name of the results layer. I hit run analysis. And this is the result set. So here's, I'm changing the symbology. Notice I'm showing that it comes up as a field in the data set. I'm going by color. I've normalized it by the total. I'm giving 9 classes. Here's my color ramp. So here's my result set, and here's my key, my legend. So again, you can see where, you know, perhaps I could look at income, could look at poverty rates, what have you. Population, there's lots of stuff that I could overlay this with. I could also look at, you know, I'm trying to, land ownership even. Yeah, thank you. Oh, thank you. Supplemental nutrient. Okay. Is the legend a screenshot you have overlaid? Yes. Yeah, what I did, basically all of these images are screenshots. So just to let you know. So when the legend here, I didn't have to do anything, but the other ones that are much longer, that have multiple layers, I had to build them in PowerPoint. I had to actually, you know, group them and crop them down. So, but yeah, everything that you see here, you can't export. You can export the data, but that's a lot of work. I didn't need to do that. I'm just showing you, you know, what the result set is. So a screenshot worked fine. All right, so the next one, analyze patterns. So sorry, I don't have an intro to this one. I thought I had included that, but I guess not. So in the analyze patterns, you're basically, you can calculate density. So again, you're basically kind of, you're creating a surface. So to me, this is sort of like a stylus tool in ArcGIS Desktop, which is why you need the spatial analyst privileges. Or even the geostatistical analyst. So again, you're creating a density map. So you're taking point data and creating kind of a surface, really. So again, it's distributing those known quantities across the surface. Now what they're saying here is that they're basically using measured values to predict unmeasured locations. So measured values at known locations. So known values at known locations, predicting for unknown locations. That's how they get this surface. So obviously, you wouldn't be able to do this with discrete data. In other words, people, unless you're doing a people per square mile. But that's a calculation. What you would have to do, so in other words, if you did people, you couldn't just do it from counts because people are not surfaces. But a population density is a surface. So if you had a point layer with a population density, you could do it with that because population density is a surface. So you could do, you know, you could calculate at that point. All right. So again, you're getting a polygon layer classified from the least dense to the most dense. The darker the area, the denser. So you can also find hotspots within using this tool. So again, you're looking for statistically significant clustering as far as in that data, the spatial distribution of the data. So in other words, where it's spatially happening, right? Where it's happening in terms of location. So some examples: crime rates, infant mortality rates, high and low test scores. So again, I do have some examples of these. And then interpolate points. This is truly where you're predicting values at unmeasured locations based upon measured locations. I believe, so this works well with pollution levels, mineral deposits. So in other words, you want to think in terms of a continuous surface, temperature, CO2 surface. So So what I did here, I just said, okay, I'm going to do a population, calculate the density of population, right? So again, it's going to be square miles. So there is that aerial component that does make it a density. In this one, I didn't do, I had no threshold in terms of distance threshold. So it just came up with these sort of isolated points. I did have an area. The census tract, I believe, is the area that I chose. On the other hand, on this one, I chose population, but I said within 25 miles of each other. So that's why you get this this surface right in here, this cluster. So again, here I have a 25-mile cluster. Here I have 50 miles. So you can see how that changes. But again, it's going to clip to that boundary. So notice for here, I have population only. But here, I don't have a boundary layer. I didn't say, to census tract. I just said just for these points. So that's why this comes up looking like this, because it's taking into consideration these cities up here. So finding hotspots, again, this gives you the input. I clicked on Find Hotspots. The analysis layer are the Yavapai cities, which is point data. So now my analysis field is population. And again, in this one, I believe it has to be a numeric value. I think the only options to me were numeric fields. So my result layer name and click Run Analysis. So you can see what's coming up. You have this gradient, but it's just the points. So it gives you this, colder is going to be a lighter color, and then the hot spots are going to be darker color. So again, it's basically looking at population centers, right? So again, it gives you an idea, and this makes sense. This is basically Prescott in this area. Okay, Sue. So then the next one, find nearest hotspot, right? This is looking at, the goal here was I want to find those wilderness areas that are within, I believe, 100 miles of one of the hotspots, basically. I didn't put a threshold on the hotspots. I just used the result layer. So the result map, you can see you get these lines representing from the wilderness area to the hotspots that are, or just hotspot, that's within 100 miles of that wilderness area. So the reason I chose this, as far as if you want a rationale for it, I just thought, hey, what if you want to do field trips to wilderness areas? How close are wilderness areas, to some of the schools? Which, of course, it's going to be a little biased because, because obviously these cities are going to impact where the wilderness areas are. In other words, wilderness areas are, by their very nature, going to be further away from high population centers. But I just thought, oh, what the heck? What if you wanted to do some field trips? How long would you have to plan for? How far are they? Things like that. So you could put in 500 miles. You could put in, say, hey, we can do, a 200-mile trip. But again, this is giving me straight line distance. It doesn't give me driving or drive time or drive distance. Again, you need a route layer for that. By the way, we're almost done, I promise. So the last option, or no, not the last option, but the proximity option, this again is looking at nearby features, and you want to again think in terms of a buffer area. So you can create buffers, right, and say, I want to find those features that are within 25 miles of the campus. So in the examples I came up with, vegetation within a specified distance of a waterway, landfill within an urban or residential area. In other words, you're planning a landfill. You want to make sure that you are, no closer than 50 miles within a population center. So you would create that 50-mile radius around your population centers, and where those areas that are outside of that 50-mile radius would be your site selection for a landfill. Of course, there might be some other information that you want to put in there, such as slope. You know, you're not going to be building a landfill on a 30-degree slope, and also land ownership. So if it's private land, you might have to negotiate. Create drive time areas. Again, you're going to need a network. Anytime you see drive time or drive distance, you need that network. So again, it's going to create a drive time or distance in a specified area. Find nearest. Again, straight line distance, road distance, drive time. If you don't have that route, you won't have these options. You'll just do the straight line distance. You can limit the number of nearest features search range. For this, you can also get some optional reports and ranks. I did not review those at all. Again, it requires a network analyst privilege, which I'm sure you all have. You just have to make sure it's selected, it's set up, your account is configured for that. Plan routes. This is where you want to think in terms of maybe FedEx or UPS, where they're basically dividing tasks and routes among a fleet of vehicles, or as they say, a mobile workforce. So your result is going to be based upon the set of stops and the number of vehicles that you have available to visit those stops. So they're looking at, basically they're looking to at least time cost. So this is sort of a cost analysis. And finally, managing data. So managing data, this is really your day-to-day management of your geographic data and, of course, your attribute data. So this is also where you might do some data prep for analysis operations. So managing data, this shouldn't say plan routes, but sorry, I missed that. But basically, you're selecting, this should say extract data. So just to make sure you understand that. I wonder if I can write this on here and have it save. But basically, yeah, it's not going to let me type in there. Maybe. Can you see that? Can you guys see that? Extract data? Okay. All right. So it really should say extract data. Not plan routes. So I'm just going to, I can't move it. No, I can't move it. Maybe I can. But let me see if I can. Okay, there you are. So in this case, you know, you're just like what I did. I said, just give me those for Yavapai County. Okay, so your selected layers are either added to a zip file or a layer package. If you get a layer package, when you basically open up that layer package in Arc Catalog, you can have you'll have the option of adding it to a map document. So once you get that added to a map document, you can export that to a shapefile, and then you have a lot more freedom with it. In fact, the cities layer came in as a layer package from the Yavapai or the AZGeo data port. So the second option for managing data are dissolving boundaries. So in other words, say you want the state boundary, but all you have are county boundaries. You can actually dissolve, if you have a field in that database, or if you add a field in that database that has the state, in other words, each county has its state associated with it, you can actually dissolve on that field. And that way you can actually create state boundaries. So it's pretty handy. Anywhere where there's a common field. Merge layers, you're basically copying features from two layers into a new layer. So it has to have the same point, line, and polygon, and you can control the attributes, common fields, and data type. In other words, what they're saying is that you have to make sure that your fields, if you don't want the fields to, if you don't want multiple different fields of the same information, you just have to make sure that they have the same data type, especially. And you should have the option of mapping field. In other words, saying this field maps to this field. But they definitely have to be the same data type. So if one field has, I'm trying to think, maybe someone wasn't sure how to represent zip codes, and they're representing it as a numeric value, and then in another data set they're representing a zip code with a text. You cannot put those in the same field. They'll come up as separate fields because they're not the same data type. And then you can also overlay layers. Again, you're combining 2 or more layers into a single layer. All attributes come in to that final layer. So in this one, again, you can do a support, or you can do basic overlay analysis. So parcels are located within a floodplain. So some of the final notes, you will probably have to perform some prep work in ArcGIS Desktop. The main thing is you really want to review your data before you just load it up into, you just want to look at your data, whether it's in ArcGIS Online first or ArcGIS Desktop. You want to make sure you know what your data is all about, what attributes you have, what the data types are, so that you know what you can do with it. Again, you have that limit of 1,000 features. So if you have a very large data set, what you could do is just break it down into separate data sets and then perform your analysis and then bring it all back into ArcGIS Desktop and combine them. So in the ArcGIS Online environment, what I found, it's pretty slow. It may not provide information about why the analysis didn't work. It also, sometimes it adds the layer to the map document automatically. Sometimes you have to go find it. So you just need to know where you're putting it in terms of your content folder. It's a bit clunky. It's just not as flexible sometimes. It just has a clunky feel to it. All right, so in this webinar, we covered the requirements, data requirements, and some of the requirements to perform analysis. We looked at the data sources and the recommendations for data. We also reviewed the pre-work that I did in order to perform analysis up in ArcGIS Online. The analysis tasks that we reviewed included the summarize data, find locations, data enrichment, analyze patterns, use proximity, and manage data. And then finally, just sort of a review in terms of what works best and what I found to be cumbersome or good. I mean, there were some good things too in ArcGIS Online. So thank you for attending. If you have any questions, please feel free to ask me.
No, I don't have any questions. There's a lot of great information there. It really is going to help my economics project. So I'm going to have to revisit this presentation quite a bit, actually. I couldn't take enough notes. So,
oh, great. I'm glad to hear it, Carrie. Glad to hear it. Or Kelly. Is this Carrie or Kelly? I can't tell.
Carrie, sorry.
Okay.
Yeah, I know.
I'm glad it was helpful, Carrie.
Yeah, for sure.
Okay. Well, that's great to hear, Kelly. All right. Well, I'm going to shut down. You guys have a great evening and have a great Christmas. Bye.
Thanks. Yeah, you too. All right.
You're welcome, Carol. Talk to you later.
You are currently the only person in this conference.